Okay, so in the last lesson, we had worked through a couple of these examples here. You see, I think we had done aluminum oxide. So let me just remind you, you put your symbols side by side, Al and O. We labeled our charges. So we looked at our periodic table and we saw that aluminum will always have a +3 charge. And oxygen is always going to be a -2 charge. And you crisscross your charges. So the 2 comes down and the 3 comes down. So we had Al2O3 for our formula, and that was in its most reduced form. With calcium hydroxide, we put our symbols side by side, Ca and OH. Remember to put your polyatomic ion in parentheses. You're now going to label your charges. Calcium is always a +2. Hydroxide, you have to remember, he's a polyatomic. You have to memorize his charge, is a -1. Cross your charges down, so the 1 comes down and the 2 came down. So we had CaOH2 for that answer, and that was in its most reduced form because our subscripts are a 1:2 ratio. Potassium iodide, K and I go side by side. Remember, we label our charges. Potassium is +1 because he's in group 1A. Iodine's -1 because he's in group 7A. Now remember that when these charges already equal 0 when you label them, then that means that the formula is already written correctly, so you would write Ki for your final answer. Keep in mind, you never want to express your final formula with any charges written in it, so that's why always you want to rewrite it and put a box around it. Number 4 was the one we were looking at on the last lesson, so let's pick back up with barium oxide. Remember I told you that barium is a +2 charge. Oxygen is always a -2. And so what I was saying was that, again, when your charges already cancel, +2 -2 already equals 0, that lets you know that it needs to be in a 1-to-1 ratio. So our formula was BaO, and that would be the correct answer. You always want to make sure you express your final answer in the most reduced form. All right, so let's look at 5 and 6. Pause the video for just a second and try 5 and 6 on your own, and then resume the video and check your answer. I'm going to go ahead and work these out since my videos are only 10 minutes. All right, so potassium nitride. So potassium is a K. Nitride, since it ends in IDE, I know it's just an element, nitrogen. And so there's our symbols side by side. Now let's label our charges. Potassium is in group 1A, so you should have said he has a +1 charge. Nitrogen is in group 5A, and he will always have a -3 charge when he forms his ion. So when you crisscross your charge values, the 3 comes down and the 1 comes down. So we have a 3-to-1 ratio that cannot be reduced, which means our final answer should be K3N. K3N. Number 6 was magnesium phosphate. Now notice the ending here. Remember, almost all of your polyatomic ions are going to end in ate or ite. Now there's only a few exceptions to that. Hydroxide is one of them. He's one of your exceptions. Then we have cyanide, and then we have ammonium. But most of your polyatomics are going to end in ATE or ITE, and that's how you will recognize them. So we know this is a polyatomic ion. It's not phosphorus. If it were just phosphorus, it would say phosphide. Notice the ending is very important to pay attention to, little details. All right, so symbols. Mg is magnesium. Since phosphate's a polyatomic ion, we're going to put in parentheses PO4. And you may be thinking, well, how am I supposed to know that? Remember, y'all, I said you just have to memorize your polyatomic ions. That's why we're quizzing on them this week. So magnesium is a +2 charge because he's in group 2A. Phosphate is a -3 charge. Now remember, the way I remember his charge is because if you look at, there's phosphorus in this formula, and if you were to look at the periodic table and try to remember what charge phosphorus will form, he is in group 5A, and they always form a -3 charge. So the same thing for phosphate and phosphite, they're all -3. So his charge is -3. Now crisscross your charges, you bring your 3 down here, you bring your 2 down here. The 3 and the 2 cannot be reduced, so that means your final formula will be Mg3 PO4 in parentheses, and outside the parentheses is a 2. This is your final formula for magnesium phosphide. I'm sorry, phosphate. Now, I said that because I was thinking I need to show y'all the formula for magnesium phosphide. Had it been magnesium phosphide, IDE, you would have done Mg and you would put a P. It's just phosphorus. Label your charge the same, plus 2 minus 3. So the 3 would come down here and the 2 would come down here. They cannot be reduced, so you would have said Mg3, P2. If it had said magnesium phosphide, again, IDE means it's just an element, the nonmetal. If it is an 8 or ite, it's going to be a polyatomic ion. Okay, so that concludes the examples for these ionic formulas. Tomorrow we will learn how to name these compounds.